Hi, everybody. Hi, Gary. Hello. Anybody out there? Yeah, I'm going to yell at them. Well, it's good to be here. This is a topic that I worked together with Greg Hoglund on, and in fact, Greg's going to be here tomorrow talking about some of the more advanced aspects of this work. But it's interesting because I'm really a software guy and not really a gamer. My last huge stint of gaming was probably 1981 when I stayed up all night playing Wizardry on my Apple II. So the book is actually dedicated to Ultima 1 and Wizardry players, in case there are any of you out there. Yeah, here we go. But games have really caught on, and not surprisingly, they've all shifted to the internet like everything else. And so they make a really interesting topic of conversation. And that's what I'm going to talk about this morning. I come from a company that works on what Bill said, making software behave, really. And I got interested in software security back in the mid-90s, working on Java security issues with Ed Felton from Princeton and his guys. And it really made me think back then, why is it that people who build these systems really screw it up when it comes to security? And if you wanted to not screw it up, what would you do to not screw it up? And it turned out that there really wasn't very much information out there in the world about this whole idea of building software to be secure. So I set out trying to build some of that stuff. And in fact, you can see exactly the same phenomenon here in these online games, which have become wildly popular, probably well beyond the dreams of the people who wrote them. You know, the guys at Blizzard probably did not anticipate having 8 million users, for example. Or maybe they did. And what happens is, when you have that many users, you get exposed to the bad people out there in the world, and they do unanticipated things. And so software security is really about trying to anticipate some things that people are going to do to your software before you even ship the stuff. And if we look at online games, we can find out what happens when you don't do that. So that's going to be kind of the take-home message. I'm going to talk about a lot of stuff in this talk which you really shouldn't do. So you should be aware of the fact that if you do some of the stuff that I'm going to talk about today, you might get in trouble. You probably won't get thrown in jail because the laws that surround gaming are more about piracy and copying than they are about cheating. And I'm going to mostly be talking about cheating today. And in fact, there aren't really any laws about cheating. So, you know, this is a very active area in the underground community. This is something that some of you probably know has been going on for several years, probably 3 or 4 years. And Greg Hoglund's been deep in the heart of it for at least 3. We started working on this book about 1.5 years ago. It just came out a couple of weeks ago. But in the course of doing some of this work, Greg actually had several characters in World of Warcraft, which is one of these massively multiplayer online role-playing games, banned. So it cost him about, I don't know, maybe 20 or so characters worth of stuff to get this stuff done. And the idea was, we wanted to start out as simple as possible, talking about how you manipulate these games in ways that were really easy to catch. And it turns out, if you try this at home, that if you do things in an obvious fashion, you in fact will get caught. And what they do when they catch you in these online games is they kick you out of the game. Then you have to go run to the store and buy a new character. So we expect you not to really break laws using this stuff either. I wanted to say that right up front. So let's talk about why online games. The main thing is, online games, I believe, are a bellwether of things to come. So I want to explain that. First of all, there are 3 things that I've called the Trinity of Trouble for many years that I think make software security particularly interesting. These 3 things make the problem get bigger and bigger all the time. The first one is somebody decided to connect it to the net. So if you think about the online games thing, back in the early days, games were not obviously on the internet. Now they all are. And do you know why they first moved onto the internet? Turns out it wasn't so that people could all play together, although that was a cool side effect. It turned out security was one of the pressures to get games to have an online component. So if you think about somebody who's trying to, say, pirate a game, which I'm sorry to admit that I did a lot of back in the 80s. You probably did too, didn't you, Yvonne? So you didn't? No? Yvonne didn't do that. But Greg Morissette, who's at Harvard, just down the road, and I lived in the same little town in Kingsport, Tennessee, and we both had Apple IIs, and we would rip each other's games, you know, and then we would trade them. And at first we did that, we thought that was cool, because we were getting everybody's games. I got his games, he got my games. That was a lot of fun, and we decided that actually it was more fun to break the games than it was to play the games. And so that's kind of how I got into all this stuff back in the early days. So imagine that you have this problem, that you just shipped the thing that you're trying not to have copied to the guy who wants to copy it. Then you see the problem. Well, there's an obvious solution, which is make part of that security mechanism online, so that you have to do a license check or some other component that's not really stored right there in the software itself. And really that's what happened with the online component of games. And so a lot of the early internet-enabled parts of, say, little games actually had to do with checking licenses and stuff. And in fact, if you look at the law is still set up to just deal with that whole notion of copying and what's allowed and what's disallowed. So almost all games these days are connected to the net, and they're connected to the net in a really, really wide way. So we all know that we've got big problems with massively distributed systems and security. And people like Ross Anderson have been talking about this for years, and Peter's been talking about this for years and years and years. It's still a big problem. It's very hard to solve. But you want to hear about a massively distributed system? World of Warcraft right now has about 400,000 people playing the game. They have a fat client on their PC that's connected over the internet to server farms that are load balanced, and there are plenty of those, probably 50 or so servers, I don't know, when you count all the particular machines. So this is a massively distributed system, not a little kind of sort of distributed system. And this is really software as a service already out there. So when we talk about things like Ajax, and we talk about things like SOA, we talk about all this Web 2.0 if you buy into the marketing hype. These kinds of systems are already out there, and the biggest one, I believe, is these online games that are just hugely, hugely, massively distributed programs. So here's the technical question behind all this work. When you have a massively distributed system like that, and it has a huge amount of state in the little universe with all those servers, how in the heck do you share that state with 500,000 people all at once in any sort of synchronized way? Well, obviously you can't do it in a synchronous way. So you have to be able to get state over to those gamers and then take it back and sync it up with the rest of the world. Well, if you're living in a happy, shiny, happy people REM universe, you know, which most software developers are, you think, oh, I'll give them some state, and they'll send me back some state, and everything will be just great. Which is a bunch of baloney, because what really happens is you send somebody who's possibly malicious state, and they screw around with it and see what you'll eat when they send it back. And that's the way things really work in these hugely distributed systems that are all connected over the internet. Number two thing in the Trinity of Trouble is complexity. And anybody who's looked at software knows that software is getting more and more complicated. There's this kind of striking irony when it comes to software and complication. And that is, in order to be easy enough for normal people to use, and I'm sorry to say that none of you out there are normal people. You're all a bunch of geeks. So, I mean, we even put geek on our t-shirts, for goodness sakes, right? The meta geeks. So we're all geeks, but normals, they really don't give a damn about how computers work. They're uninterested. They might want to play a game, right? But they don't want to know about any of that other crap and even connecting to the net. They just want to turn on the machine, boink, off you go. So in order to make things simple for normals, we have to make them ridiculously complicated underneath in the architecture. So a thing like a web browser looks like that. Even my grandma can use one. And you look under the covers, and it's really a complicated thing. These games are way complicated. These game clients, which I'm going to talk about, doing a little reverse engineering on some of these things, they're complicated programs. So we're not talking about a simple program as the client, and we're not talking about a classic von Neumann or maybe Peter Neumann architecture where you have a thin client and a big fat server. We're talking about big old fat clients that do lots and lots of stuff. And that's one of the issues we have to grapple with too. And then the third thing is extensibility. All modern software is built to be extensible for obvious economic reasons. Here's the reason. You can't ship the whole thing today. We're already behind schedule, right? So what we're going to do is ship part of it and stub part of it out, and later we'll just ship them some new class files. We'll rebind that stuff into the environment. Everything will be fine. We can do update all the time. You turn on your computer. It says, oh, there are 900 patches from yesterday. You want to apply them. Yes, I do on my Macintosh that has just the same problems as everybody else. So this extensibility is a big issue too. It's a big issue in these games as well. And in fact, the biggest game of all, World of Warcraft, just had a major release of a new piece of the universe, which was just a way of extending the universe and adding some new stuff. And they changed a bunch of the rules. Like, you could have a character, like you get a little elf or an orc or, I don't know, troll, whatever you get. And you become a little type of person, maybe you're a priest or a fighter, and they can get levels. You get up to level 60 in the old days. Now you can get up to level 70. Now, who has a level 70 character in here? Anybody? One guy. Wow, that's it. Two guys. That's good. Anybody have level 60 still? Last time I gave this talk, what's the new world called? Outland? Okay. So I thought it was Burning Crusade. Is that? That's the name of the expansion. Okay, so. Oh, level 80's out. Right. Are you level 80 yet? So what? I mean, sure they can do that for you anyway, right? You could have some guys in China do that for you. Okay, excellent. Good. So these things are all very interesting. So we got this Trinity of Trouble thing, and then the reason I'm really interested in this is because these games are just huge. So I said, you got 500,000 people playing, 8 million people play World of Warcraft. And so we got about 12 million people worldwide playing all the games. It turns out Warcraft is about 53% of the market. I'll show you a little pie chart in a minute. And these games really push the limits of software technology. So as we think about the kind of problems that I'm going to talk about this morning, the thing to really take home is, well, how do these kinds of lessons about time and state and trust boundaries and how much state I can give to the client and what I do when I get this crap back, these are the kinds of lessons that we need to apply to all of our software systems. So maybe because games are cool and they're fun and, it's an exciting topic, we'll get more people to understand some of these intricate aspects of building software properly. Here's a little growth chart of these games from January 97 until June of last year. See that growth? Goes way, way up. And it's super linear, which is pretty interesting. So obviously we've escaped the geeks only, right? And now we're poking well into the actual normal human beings out there in the world. And whenever we do that, interesting stuff starts happening. And when you get piles of people that are, say, greater than 12 million, there are just a few bad apples in that pile, right? In fact, probably when you get a group greater than 3, you might have a bad apple. Around here, all you need is just a group of 1, and you have a bad apple because we're all a bunch of security people. So, just do the math and you can see how many bad apples there are in there. They're also big business. So, sure, you got 8 million subscribers, but guess what? Each of those 8 million people pays $14 a month to play this game. So let's do the math. 14 times 8 million is 112 million times 12 months is $1.3 billion just for subscriptions, right? Plus you had to buy the expansion kit. How much was that? 20 bucks, something like that? It was free for you? It was in the noise. That's good. Yeah, yeah. You know, you go out to the store, maybe you buy the client for 50 bucks or whatever, so that's another $1 billion. I mean, we're talking about lots and lots of actual real money, but that's not the most interesting things about these things. There's a huge market for this pretend stuff. So you have a character, and your character has a Vorpal sort of hainosity and a whole bunch of pretend gold, and that stuff, and in fact your character itself, turns out to be worth money. Now, how would that be possible? Well, obviously there are people who are lazy and they would rather not play the game. They'd like to be a level 80 who's-he what's-it, you know, right out of the box. And it turns out you can be if you have enough money on your credit card. You just run over to IGE and you buy yourself a big character, and then, you know, you get into Warcraft and you're a level 70 whatever, and you're a noob, which is really interesting. So we, you know, sometimes people do this, but there's a huge market for this stuff in the middle. And there are exchange rates between pretend gold and US dollars. So that little chart right there is the first half of 2005. You can see that the pretend gold was getting worth less and less, but it was still worth money. Now that's probably a sign of inflation in the game. You know, those guys actually decide how much wealth to inject into these games. They actually have whole staffs of economics people, economists, working on these games in order to keep the economy flowing, because these little worlds have real economies. Some of them are particularly interesting. You know, that there's a game called Ultima Online. Anybody ever play Ultima Online? Anybody have bright red hair in your character? Yeah? So you know about the inflation stuff. Yeah, so this is really interesting. See if I get this right. Somebody discovered a dupe bug. And a dupe bug is a bug that allows you to duplicate items. So this person decided, well, it'd be cool to duplicate money. So they started duping money. Well, instead of keeping this to themselves, it wasn't you, was it? Oh, good. So instead of keeping this to themselves, they told their friends, who told their friends, who told their friends, who told their friends, and pretty soon everybody was duplicating gold, which meant that gold was really piling up, like all around. And you know, gold became worth not very much at all. And the Ultima people had runaway inflation like, say, Brazil, you know, like serious, Brazil 10 years ago, serious runaway inflation. So they called up an economist and they said, oh my God, there's gold everywhere, what do we do? And they said, well, you have to get the M2 down. This is the money supply. So you have to figure out a way to pull money out of the game to get the economy to balance back out. I said, well, how do we do that? Well, you invent a commodity that's worth insane amounts of money, and then you just cause people to want to buy it, and you just extract the money out of the game. And so they invented bright red hair. And you could buy bright red hair for what? Huge amounts of money. Yeah, if you don't know, huge amounts of money. And so there are now some characters running around Ultima Online who have bright red hair, which is apparently cool because that meant you once duped gold. I don't know, right? But they balance the economy back out. So you see, these real economies and these virtual economies have gotten big. They've got ties to the real economy. And in fact, there are some economists, some academics, Castronova comes to mind, who's a professor at Indiana University, who believe that the GDP per capita of some of these virtual economies is larger than the GDP per capita of normal economies. So you look at Warcraft and you say, well, that's bigger than Russia's economy per capita, which is nuts, but it's true. So we have this whole money thing. Now, you can imagine if there is a way to take, say, a dupe bug and turn that into actual dollars, or there's a way to sell your level 70 character to IGE, that all of a sudden we have real incentive for those bad apples that were in that huge population of people that are doing this to cheat. Because if you cheat, you can get a character, you can grow them, you can get all sorts of stuff, and then you can sell it for actual money. And so not only is it interesting from a technical perspective what we can get away with because of the design of these games, but it turns out you can also make a living doing this. And some people have done pretty well over the years. Now we pick on World of Warcraft, and here's why. World of Warcraft is the light blue pie piece, and all the other games are the other pie pieces. So it's obvious which one is the most popular and which one is the one you really ought to talk about. But the reason we had to choose one particular online game was because in the book we wanted to not just talk about platitudes, we actually wanted to show code. So we needed to write against a particular target. We had to disassemble the Warcraft client. We had to figure out how to build a botting system for the Warcraft client. So we picked Warcraft because it's just huge. So there's the thing. Now, some of you have heard me talk about this before. Isn't it bad to talk about attacks and how things break? Well, I think it's not. And if you look at history, we see that people in network security became sane over time. So back in 1995, Dan got fired with Vitsa. Is Vitsa in the audience? I know he's here. You here? I don't see him. So Dan got fired from Silicon Graphics for releasing Satan. And they told him they were going to fire him, and he got fired. And then he immediately got a job at Sun for $5,000 more the same day, which is what used to happen back in the 90s. Remember those days? Those were when I was trying to pick off Patrick. Yeah. Right. So we were .com, man. Sorry. So 2007, you don't use something like Satan, what happens? You get fired. So that's great irony right there, right? It goes from, ooh, possible hacking tool, too dangerous, we'll fire you if you release it, to if you don't use one of those every day, we're going to fire you for incompetence. We haven't quite gotten there from a software perspective. We got a ways to go. There's still people who are getting in trouble for teaching virusology or whatever you want to call it, or malicious code, or talking about software exploit. But I believe strongly that you cannot do computer security without really deeply understanding what bad guys are doing, or what bad guys could do. None of the stuff that's in exploiting online games is going to come as news to people who are doing game hacking for a living, for God's sakes. They're way ahead of this. And there were a couple of places where, I had to think about where is the edge? How far can you go, before you get sued in one case. So we actually had a little piece of code that would disassemble WoW packets, and that involved extracting the key from the WoW client, which is really obvious because the key's just sitting right there, right? But we decided that it would be best not to publish that, even though if you're halfway smart, you can do that in about 5 seconds yourself. On the other hand, if you need to think about how bots are constructed, you actually have to build code to do that. So we built lots of code to do that sort of thing. So here's what I think about all this. I think people tend to be interested in exploits because it's kind of like the reason that people watch NASCAR. They watch NASCAR for that, right? Boom! All of a sudden there's a new saint. You can put his number on your truck. It's all good. I can say this because I'm from Virginia, right? And Dale Earnhardt, baby. So the world loves to talk about how stuff breaks. It's, rubbernecking. If you think about it, software exploits kind of like rubbernecking. But if we can use rubbernecking to get people interested in building things properly, that'll be great. People would rather not talk about, say, car architecture, right? How to build safer cars. That's boring. That sounds like Volvos, right? So anybody want one of those? No. You have to have one when you want one? Got kids? Okay, there's a safe person over there, right? So we can use this notion of exploit to really get people to think about how to build systems that can't be so easily exploited, and I think we have to really do that. All right, this section of the talk is called Lawyers, Guns, and Money. I think one of the most interesting things about exploiting online games is that it's got this intersection of all these fields. As I mentioned before, you know, the law really hasn't caught up to the whole online game cheating thing. It's like not against the law to cheat. And in fact, why would people make laws for silly things? I'll give you an example. I used to play Tetris with my wife, Amy, in grad school on a PC. And we would play, you know, we played a lot. We got pretty good. It was competitive. And there was the high score file, and you always wanted to be at the top of it. Well, Amy started playing more than me, and she got better, which sucks. So I just hacked the high score file, you know, and I made it like a gazillion, bazillion, trillion, billion points. And she started playing, and she said, God, how did you get that score? She came to me, and then she goes, wait a minute, that would have taken 5 days. It's like, ooh, I didn't think about that. I should have made it high, but not so high. See, I wasn't being very clever. But there's no law against hacking the high score game on your own PC. Why in the hell would there be a law for that, right? That's crazy. And that's kind of where we sit. So the law caught all the way up to Tetris, right? To say you can't copy Tetris and give it to your friends in case you can't find an open source version. But when it comes to online games, it doesn't say anything about you're not allowed to cheat. You can't, like, you know, collect leaves and sell them to the elves automatically or whatever. So we got a ways to go. And the lawyers are all over this. So the cracking games cost money, and of course there's a lot of case law. There's some really interesting case law that the EFF was involved in over what constitutes cracking and piracy, and whether or not you'd be able to build your own BNetD server, open source thing. And you know, those guys lost their case. The BNetD guys lost their case because they actually had to get into the security mechanism and reverse engineer a piece of the crypto protocol. So it fell under that anti-piracy case law. See? It wasn't about cheating in that case. It was about kind of the revenue model, how these game companies make their money selling copies of the game. So now we have security mechanisms that protect against that sort of cracking, and most of those use online components. And so if you're going to cheat in an online game and you really want to avoid legal entanglements, you have to get way away from that. That's why we didn't put the code for decrypting Warcraft packets into the book. Although you can get it if you go out and get mangoes. I mean, it's just there already. And of course, the thing is, even though the law hasn't evolved, they're still using the old laws to try to stop people from cheating. In particular, the Digital Millennium Copyright Act is being used to counter cheating, which is a real stretch if you think about it. You know, because we're not talking about trying to copy anything, really. We're not talking about ripping off the game client. We're just talking about cheating in the game. So, you know, we're in a really interesting time legally. And there are some property law issues, too. So I'm sure many of you, everybody's probably heard of Second Life. Second Life is interesting because instead of owning all the stuff in the virtual world, the Linden Labs people decided to allow you to own the stuff. Now in Warcraft, if you play Warcraft, you don't actually own the stuff. You just have a license to the character, and all the things that you think of as yours, they actually still belong to Blizzard. Right? And in fact, one of the things we had to do, they own all the screenshots too. We have screenshots in the book. We had to get permission from Blizzard to have screenshots of you doing stuff you're not supposed to do in Warcraft, which was very interesting. But we did manage to pull that off. And so when it comes to Second Life, though, the property belongs to you. Now, there was this one fella who discovered a way through URL parameter tampering to manipulate and win auctions for land. And so this guy became a real estate baron, owned all sorts of land in Second Life by exploiting a bug, a really stupid web application bug, really, really stupid bug, right? So Linden Labs found out that he was using this bug, and they took all of his land away. They said, nope, you're out. And you know what happened? He sued him. He said, wait a minute, that's not your stuff. That's my stuff. I don't care if your software had a bug. Tough. That's my stuff. So give it back. Now, imagine the poor judge. This case is still in court. Imagine Imagine the poor judge who has to figure this out, you know? It's like, let me get this straight. You had pretend stuff, and you figured out how to get the pretend stuff, and you're suing him for real money about the pretend? Go away, right? See, so, you know, how's this case going to come out? Who the heck knows? Nobody's really sure. There's not a Second Life judge, you know. They're starting to become kind of moralistic, though. They banned gambling just last week, or 2 weeks ago. Yeah, right. You could duplicate that. There you go. Actually, in Second Life, there was one bug once that was a dupe bug on this little object, and this guy filled up the entire universe with goo. It was just stuff. They had to reboot the whole game, which is yeah, lawyer bots. Oh, this is scary, right? So what these game companies are doing now is using these end-user license agreements to kind of govern your license, your use of the game. And these EULAs are just unbelievable. EULAs are really interesting in their own right. And here's the thing you should know about EULAs. Just because you clicked I agree doesn't mean that what they want you to do is legal. So even if you say I agree, you can still say that was an egregious constraint on my liberty, and the EULA won't hold up in court. So here's some really, I started looking into EULAs for the chapter on the law. Here's my favorite ones. You know, so we all heard about the Sony rootkit case, where Sony actually put a rootkit on CDs to protect music. Everybody heard of that one? Right? So I think this is fair punishment for listening to Neil Diamond. But I don't know about you. You know, if you listen to Neil Diamond, your box should be rooted. Too bad. You know, that's just the way it is. But nevertheless, it's said in the EULA, we are going to root your box, and we're not going to allow you to do this, that, and the other. Okay? And people are like, okay. But guess what? It didn't matter that the people said okay. It's still not legal what Sony, BMG, did in that case. In fact, they got sued by a whole bunch of states' attorney general who consolidated the cases, and they lost, and they had to settle for something like $1.2 million. And then they had to do an even harder thing, which was figure out who all they had rooted and try to unroot them, which turned out to be harder than they thought. Because, you know, finding rootkits, kind of difficult. You know, so their first thing was this ActiveX control that would run around and try to undo the rootkit, and it would get on your box and undo the rootkit, and then open itself up for scripting to the universe. It's like, wait, what's worse, being rooted by Sony or having a remotely exploitable ActiveX script system on my box? All right, so that's one interesting EULA. Blizzard has a EULA. If you're playing Warcraft, do you know about the warden? I assume you do. And do you know about the governor? Okay, so there's this system in Warcraft called the warden, which will monitor your PC while you're playing the game. And the question you might ask yourself is, what exactly does the warden do anyway? So we were really interested in that, and Greg Hoglund wrote a program called the governor, which watches the warden watching you. And the governor found really interesting things out about the warden. Like the warden doesn't just stick around in the WoW process space. It actually looks around at all sorts of other processes on your PCs, and will look at the names of all the windows that happen to be open. We'll check out your instant messenger client and figure out who you're instant messaging with, and look at what websites that you're looking at. And basically, it's a piece of spyware. Now, last time I checked, you're not allowed to install spyware on somebody's box in California, even if they ask you to. But so far, nobody's bothered to take the Blizzard guys to court. See, what happened was Blizzard became aware that people were cheating like crazy in ways that I'm going to talk about here in a few minutes. And so they said, gosh, we have to work on this. But instead of working on it by changing the architecture of the game and building a better way to get state from the server to the client, they just said, well, let's just install a big brother program and keep an eye on those guys. Well, it works too. So if you're using the warden and then you run out and get, say, Bubba's Warcraft hack. Do you know about Bubba's Warcraft hack? No? Gosh, you're not cheating at all, are you? Do you know about ThoughtBot? Oh, yeah. Are you using that? Oh, yeah, then you are cheating. Yeah, the website. Yeah. A friend, right, yeah. I have a friend who did that too. Yeah. Yeah. It said, yeah. Exactly. And he got banned. Exactly. So that's what happened. There can be some false positives, and you can get banned from the game. And they actually use the warden. It's pretty successful. If you run Bubba's Warcraft hack at all, if you even put it on your hard disk, you'll probably get banned within 2 minutes, which is, they're looking at your stuff. They're in your stuff. And so whether or not you think that's cool to have them in your stuff, well, that's, interesting. But the EULA says they're allowed. Yeah, you have a question or a comment? Yeah? Probably so, yeah. So can you cause your little brother to be banned? Yes, you can, right? And the banning is really damn quick. He's rubbing his hands. This is not good. This is not good. See those bad apples I was telling you about? One of them's over there, right? So there's some even better EULAs. Here's a really good one. Gator, these guys created adware, spyware, that watched your web surfing and then gave you appropriate ads or whatever. And their EULA said, if you install this software, you're never allowed to disinstall it. You can't take it off, right? I agree, click. So what kind of crazy EULA is that? Just it's not your PC, but if you install the software, it has to stay on there. And here's a good one. Microsoft had one that said, if you use Front Page to do a web page, which was a web page design tool, you're not allowed to say anything bad about Microsoft. It said that right in the EULA. Isn't that great? It's like, if you use this software, you trade in your First Amendment rights. Now, do you think that would hold up in court? No. A eulogy, oh no. And then Apple has a EULA now. Anybody use iTunes in here? Anybody ever heard of iTunes? Yeah. Do you know that you've agreed to whatever the heck Steve Jobs thinks up whenever? Because it says, you're bound by this EULA and any other future EULA that we decide to release. And you're like, okay, that's cool. That sounds a little open-ended, So there's a new evil empire. And here's my most favorite EULA of all. There was a virus that came through the internet by, looking at people's contacts and mailing itself out, that would arrive and it would say, hi, I'm a virus. I would like to spread myself by looking at all your contacts. Okay? In the EULA. People clicked OK. Now, is that a virus, or did they mean to install it? And if you get yourself licensed onto somebody's, are you still malicious code? These are all real EULAs. So as you can see, the state of the law is a little bit tricky, and then we got the whole property law thing, and we got the who owns what thing, and oh, geez, it's really, really complicated. It's fun to watch. There are several active cases that are going on now that I think are going to be very far-reaching because, we're talking about massively distributed architecture. It just happens to be games, but in the future it's going to be other kind of digital assets. And so some of this property law about digital assets is going to affect lots and lots of other stuff. And really right now, it's just a wild free-for-all. Nobody's really sure. Okay, so that's the lawyer's part. Here's the guns part. There's really nothing to do with guns in online games. So I just have a picture one. And then we'll talk about money. I just had to work that in, So I already said that there are exchange rates between in-game currency and real money. And I already said that the GDP per capita in some of these massive multiplayer online games are bigger than the GDP of some real countries. And this market is huge. Microsoft said $6 billion in 2005, and DFC says that's going to double by 2010. That's an online gaming analyst company. So, this is serious money we're talking about here, bigger than Hollywood, really. So, and the secondary markets are huge. So you used to be able to go to eBay and buy World of Warcraft stuff and other stuff, but eBay decided they're not going to allow people to do that anymore because these transactions are a little bit tricky if you think about it. If you want to sell your Vorpal Sword of Hainosity to another character through a third party, then you actually you have to take the item in the virtual world and put it somewhere, and then the other guy has to get it. And then the money has to change hands. And as you can imagine, there was just a little bit of fraud. Sure, I'll give you 20 zillion pretend gold pieces for 100 actual dollars from your credit card. Just meet me here in this dark alley and send me your credit card number while you're at it, you know. So eBay got tired of dealing with that sort of thing, but there's a company called IGE that is based in Hong Kong. That's the world's largest middle market. They have about 420 employees. They made about $400 million last year, being a middle market for pretend stuff. So you can see that this is, you know, this is a serious sub-economy even. So if you want to buy yourself a level 70 character or some item or whatever, you can actually do that by going to IGE and just buying it from them directly. And even better, if you figure out a clever way to cheat where you cannot get caught by the warden and banned, then you can develop this pretend stuff and actually make real money for it. You know, and people pay real money for pretend stuff all the time. This is my favorite one. There's this one fellow that paid $100,000 for an asteroid space resort. Anybody play Project Entropia in here? Usually there's one. Nobody? I've never been to this guy's asteroid space resort, but I sure hope it's cool, you know. Geez, 100K for bits. And, you know, we talked about Second Life. Here's the most interesting aspect of the money thing. It turns out that you can make wealth by playing these games. And the question is, how much wealth can you make per hour? Well, I mentioned ThoughtBot a minute ago. Here's what ThoughtBot is. It's actually a proxy solution that you play the game and you're connected to the game through this channel, and at the same time you're teeing off all the data and you're sending it over to ThoughtBot too. And what they're doing is keeping track of what you see and what you do and what stuff you run into in the world, and they do that for maybe 100,000 gamers at once. And so they build up quite a database about where stuff is in the game, and then they can give you back that data, which helps you play more effectively or have more fun or whatever. And they do that as a service. But the real reason they're doing that is because they're deeply connected to IGE, who is deeply connected to these people who pay people money to play the game, and they want to maximize the amount of wealth that they can create in the game. So there are these little farms of people in China who get paid $3 a day or so to play World of Warcraft all day long, and they can make about $1.25 an hour or so worth of stuff using ThoughtBot data. So the ThoughtBot data is critical to being able to maximize wealth that you can pull out of the game. Does that make sense? And a lot of people, you know, when you think about cheating, say, well, where do you draw the line? Well, would it be cheating to write a macro to cast 3 spells and jump through a hoop? Oh, no, that's not cheating. Well, would it be cheating to use ThoughtBot? Oh, no, that's not cheating. I don't cheat. Would it be cheating to write a debugger that attaches to the game client, manipulates state? Oh, yes, that's definitely cheating. But where you draw that line is always really, really tricky. See? These guys choose this job because it's better than making shoes, right? And you can actually pay, you know, make real money off of these games for the middle market. So there are some estimate about maybe 500,000 people that are doing this game farming in China right now on games like World of Warcraft. And that's really interesting. So, you know, you think about all the people in this little universe. Are they all actually playing the game? Are they trying to make money? Are they cheating? How many people are cheating? If I'm not cheating and everybody else is cheating, that sucks, right? So, and the game companies, they know all these things. They're trying to probably figure out how much cheating can happen before people just bail and get a new game. And, you know, these are all really interesting things going on right now. You want to launder some money? That's how. Launder money through there. Talk to Secret Service. They're utterly clueless, totally, completely clueless about this stuff. Now, they might be getting a clue because Second Life's getting big enough press that maybe they'll get a clue. But that's a great way to launder money. Pretend stuff, Vorpal Swords of Hainosity. Let's talk about how you cheat. I'm going to talk about bugs in the game that are just kind of mistakes that the programmers make, and then bots that allow you to play the game automatically in sort of the evolution of bots. So there are two kinds of major cheating. One kind is exploiting actual bugs, and these bugs will allow you to do things like teleport or dupe gold. I explained the one bug that you could use in Ultima Online to dupe items and see stuff you're not supposed to see. And a lot of these bugs involve really kind of weird state transitions. So, you know, you can imagine that these games get tested in the way that only software gets tested, which is like, oh, you test it for 5 minutes and then you ship it. Right? So you test the normal things. But if you try abnormal things in the game, lots and lots of really weird crap happens. So you do things like check your inventory, step through the portal, pull the Ethernet plug. Bet they didn't do that test, right? Or give your friend 1,000 gold pieces while you're stepping through the portal and pulling the Ethernet plug. Or, you know, start fighting that guy and lag the hell out of that section of the internet using your bot network while you're killing him. Or, you know, there are all these interesting ways of unanticipated state interactions. And in World of Warcraft, you can do this magic stuff. You can cast spells, and often you can cast more than one spell. And it's certainly the case that those guys that wrote the code were not thinking about what happens when you cast 18 spells at once. Because when you do some things, I mean, there's stuff you're not supposed to do. Like, do you fly around the world, or do you actually walk or ride your steed? What do you do? Do you teleport? You do, don't you? You don't? Okay. Well, here's a really interesting piece of state. So it turns out that the location of the character is something that's hard to keep track of on the server, so you just give that to the client, right? So I'm giving you your location. You have control over your location, right? So what do? You find your location, you change it. You say, this is my new location, Mr. Server, boink, teleporting. Ever teleport? It's cool. Should try that. I mean, finding the location is nigh on trivial. And it's just 3 little numbers. And you just change the numbers and no more walking, right? No more walking. So that's a piece of state that really they shouldn't be giving to the client. Now there's lots and lots of state like that. That's just a particularly easy one. And so the question is, what kind of design could you come up with that would protect that state? Well, you couldn't really crypt it all up because, you know, they're going to decrypt it. It's got to be on the client anyway. So maybe something simple like computing a low-resolution vector over the top of all the state, you know, before you hand them the state, and then when it comes back, you compute a similar vector and see whether or not they've just gone like this. If they've gone orthogonal on you, then you know they're doing something fishy with state. On the other hand, if they're just sort of, you know, moving the vector around like a normal character would while they're doing whatever, then you're okay. They don't do any stuff like that right now, these games. They'd rather just get on your PC and monitor all your stuffs. And then there are bots, and there are bots that are used for combat, which are, you know, they're aim bots for these first-person shooter games. See you, Peter. And, excuse me, one of my favorite aim bots is for, I can't remember the name of this game. Shoot, doesn't really matter. The way it works is, you know, you're in a first-person shooter, you're running around shooting your enemies who happen to be the people you're playing with on the land. And it turns out that all sorts of information is being shipped to the video card in your PC. But it's not being rendered to you because you're supposed to have your first-person view of the game, so you can only see certain things ahead of you. However, your own video card knows lots of stuff, like where the enemies are, how to render walls, and all sorts of other things. So if you get into the video card, you can tell it to do certain things, like, oh, you know, why don't you just make those walls transparent? And how about if you paint my enemies fluorescent orange? And oh yeah, while you're at it, how about if every time I shoot a bullet, it lands right there over their nose, right? And I can also do a triple gainer and shoot and still hit them right over the nose. Right, so these are the sorts of things that you can do if you build yourself a decent aimbot that gets sort of below the game, think about it, by manipulating the graphics rendering part. And there are some macro systems that you have to be sitting there using your PC in order to use. There are some that you can run and go away. And there's some that will do legal inputs only. And there's some that will attach to the game client and do all sorts of totally not legal stuff. Now, why would you want a bot? Well, imagine this. If you want to get from level 70 to level 80, you actually have to play the game a lot. That's no fun. It'd be better to just have some guys in China do that for you, right? Or, maybe you can figure out a way to get experience points and gold automatically while you're, say, working at 7-Eleven or whatever you do. So the way some of these bots work, they just automate the play of the character. And some of them use the GUI. So you've got your graphical user interface right there in front of you. You got to click the mouse, type into the keyboard. And some of the bots actually use the front door of the game. Now, these bots are pretty straightforward. It's kind of like capture replay tools for software testing. And there are many, many macro languages for doing this. So farming bots that use that sort of right, on top of the game, obvious hacking are very, very common. I've talked about aim bots already. And then there are other sorts of bots. Now, those bots use macros. So you have a macro language for the game. Sometimes the games even provide it themselves. And they do that so that you can say, whenever I press F1, that means cast this spell, jump through the hoop, and do that. And so you just use those to write an even bigger, more extensive macro. Then there's some bots that get into memory. So the teleporting thing I was talking about before. It'd be nice if you could use teleporting to get around the game, but you do it in automatic fashion, so you build a bot to do all that teleporting for you. Then there's another kind of bot that interposes between the DLLs in the system, or maybe even replaces the DLLs in the system. So you're actually getting into memory and changing the program itself. Then there's another sort of bot that attaches to the game process as a debugger and just uses the methods that are defined in the game to do botting. So you can see this sort of big collection of bots that have been developed. And we've got kind of code in the game, sorry, in the book about this. This first kind of botting using macros injects keystrokes and mouse movements really into the game. There's a tool that we use called the AC tool, which you can buy. It's actually free. Some of these are free and some of these you have to buy. But in order to use this kind of macroing system, you actually have to have the game running on your PC. So your PC is like sitting there, and your player might be automatically playing. So we wrote a little bot that we called the WoW Aggro bot. And this would take your character and you would camp them, you set up a little tent, and you wait by a monster hole, and then the monsters come out and you go over to the monsters and you stab them until they die, and then you go stand in front of your tent again. So that's the way the macro worked. And it's just a little state machine. You keep track of what you see out there, and you have your guy do these various things. So here's a little picture of what happens after you do this. This is a character of Greg's who got banned called Zanier. And that's a little pile of gold left by monsters that got killed after Zanier played all night long. So Zanier got caught and got banned because it was using the AC tool in an obvious fashion. And the game masters know that people are going to do this kind of very simple botting. See the little pile of gold, right? It's kind of shiny. So they know that happens, and sometimes the game minders will come along and they'll IM your character and say, hey, ask you a Turing test question, or how's the weather, or something that is beyond ELIZA level in responding to. ELIZA is this famous AI program that just takes keywords and says nonsense. So one of the techniques that these game minders use is trying to interact with the gamer to see if they're really a human or whether they're a program playing the game. Well, there's this one guy that we know who built a botting system that's pretty sophisticated. It wasn't as simple as this. But whenever the game minders IM his characters that are playing with bots, it actually SMSs his cell phone. And it sends him the little text of what the game minders asked. So he can say in the middle of a meeting, hang on just a second, important phone call. Type in a response to the game master. Oh, you know, I got to run to the restroom. Sorry, see you later, bye. And log himself out or whatever. And he uses that to appear to really be playing his 10 characters while he's also working. So, you know, people do all sorts of things to avoid getting caught. But if you want to do botting, probably process manipulation is the easiest thing. And that's this. You get into memory itself. So maybe you change the DLL, or maybe you write a little program to look for those coordinates of your character and figure out where they are and change them programmatically. So here's a little GUI for something called Bubba's Warcraft hack. And you can see X, Y, and Z. See those right there? You can change those coordinates to teleport yourself around. And there's lots and lots of decisions that get made by these games according to state that you're theoretically not supposed to know, even though it's sitting on your PC. So this is pretty interesting. The GUI-based macros actually samples pixels on the screen, so you'll look at your health and you'll look at your location and other things. But the process manipulation macros, bot systems not based on macros, sorry, will actually get down into the process itself. So you're reading data directly and manipulating it directly. And you can build yourself, obviously, fresh exploits doing this sort of stuff by going really fast or teleporting around. There's a technique in the book that we have called ping-ponging that's a way to do fighting. And it takes advantage of this teleporting thing. And so you figure out where your enemy is and you figure out where you are. And you always teleport up and to the left of them where their armor is the weakest, so that you can stab them in the back. And then you teleport back away. So it's like ping pong, ping pong, ping pong. And you win every time if you do that sort of thing. Even if you're like a silly kind of character that doesn't normally fight, combat fights, you can still win every time if you use ping ponging. And that's a process manipulation based thing. Now, of course, this kind of hacking is known by the game companies too. So they actually, with the Warden that I was talking about before, take a look at what DLLs you have loaded and make sure that those DLLs haven't been manipulated. Now, the only disadvantage that they have in this Warden idea is that their processes are all running in user mode, right? So you can imagine that if you did your kind of process manipulation stuff down in the kernel, that you could get away with things that they could never see. And in fact, there are some process manipulation things that work in the kernel too. I'll show you one in a minute. But before we get to that, there's a kind of, so we've talked about using the front door kind of over the game. We talked about getting under the game by being the video card. Talked about getting in it a little bit. Now we really want to get in it by hijacking the thread that is the game itself. So we attach to the process very much in the same way that a debugger attaches to any old process, right? And then when you do that, you can call internal functions automatically. You just know where all of the methods are laying around and you find their addresses and you call them. Then you don't even have to have the GUI open anymore. All of a sudden, you can attach to the process and you can run a whole bunch of those processes and you just minimize them. You don't really need any output if you're running your botting program that way. So the people that are really doing this for money are kind of doing this level of stuff. And then whether or not you do this in user land or in kernel land is kind of separating the wheat from the chaff right now in terms of what's going on. Here's what thread hijacking looks like from a high-level perspective. Now you've got your WoW process, and it's got a main thread, and inside the main thread there's this one method called render world that gets called like all the time. Render world is just constantly called. So there's a big loop. It's looping. Zzz. Every time render world calls, we want to just run a little patch. We use detours because Microsoft gave it to us, so that's cool. And run over to our injected DLL, do some stuff, change state around, do whatever we want, and then return control back to the normal thread. So actually what's happening is we got a little side program or a DLL or a library that we've been manipulating, and this is how classic thread hijacking works. And the problem is, of course, the warden can see that you have injected a DLL, or maybe you've changed the interrupt address table or however you did your DLL injection. So it's pretty easy for people to catch you when you use this technique. This was something that people 2 years ago, everybody was doing this, and then they started looking for that. So not many people are doing it quite so obviously anymore. But we've talked about several techniques for cheating then. Getting over the game and doing the GUI, getting in the game, manipulating memory objects directly. You can even find stuff in the game that way, you know, if you know how to search through for interesting things in your memory. Getting under the game by playing around with a video card or being the graphics card or whatever. And there's also techniques for being outside the game. I was talking to somebody from Cambridge this morning, and they're actually working on some ideas that have to do with network sniffing. But really, frankly, not a lot of game cheating goes on with network sniffing these days. Of course, all of the interesting packets with the state are going between you and the server, so why the heck not just pull a man-in-the-middle attack? And of course, their crypto's lame because they gave the key to the client, and then they gave you the client and the key. It's just classic, stupid, bad design, right? So, but you know, it's kind of like when you want to exploit software, it's really a pain to do it at the network level. It's much better, I believe, well, I'm a software guy, to just get in, disassemble the client, and screw around with the code itself instead of trying to do it over the network. But there are a few people that are doing it outside the game. There's also this stuff, which we have a little bit on, called total conversion. Probably the most ridiculous total conversion involves nudity, like that. And so instead of skinning your character with armor and swords and stuff, you just make them look naked. I guess gamers need to get a life or something. But there's a nude patch for some game. And then, you know, you can do all sorts of things. You don't just have to change the armor to be like naked people. You can also change other aspects of the game. Like this is a good one. This wizard right here is casting a fishing line. And we changed the lure to a locomotive, so he's about to sink, right? And you can do all sorts of stuff. You can change everything in the client. If you think about it, here's the problem. You got a server that's expecting some protocol. Then you got a client that has to talk the protocol. If you just crack the client off, put whatever you want there, as long as you're talking the protocol, interesting stuff can happen. So you could build a game on top of the game engine that looks completely different. And people have done this. You know, so you could have a World of Warcraft version that has Teletubbies and magic mushrooms and unicorns and it's pink, right? And you have conversations instead of fights. I don't know. So there, you could. Not that anyone would want to do that. But you can replace all the client logic. And so the question is, how much do you replace? Are we just going to replace the video elements? Are we going to replace the physics of the game? Are we going to replace the way people walk around in the universe? What is it that we're going to swap out? And so right at the edge of game hacking right now are these total conversions and modding. And there's some total conversions that actually ended up being more popular than the original game. So Counter-Strike is a perfect example. Anybody play Counter-Strike in here? You know, Counter-Strike's actually built on top of another game. What's that other game called? Half-Life. So Half-Life was okay. Counter-Strike's way cooler. And the guys who built Half-Life knew about the Counter-Strike stuff, and they decided, well, heck, as long as those guys are building their game on top of our game and you have to buy our game in order to play their game, what the hell, right? That's good. Send more money, they said. On the other hand, some games are like, no, don't touch our stuff. That's our stuff. You can't make it into Teletubbies, for example. And so, you know, your mileage may vary there. You have to check whether or not total conversion is allowed. If you do a nude hack, that's just for your own jollies, you know, whatever. We have a whole chapter on that stuff too. Now, probably the most interesting stuff that's going on in the gaming world now involves kind of kernel level manipulation of the game so that you're undetectable. So, you know, they can detect when you change the DLLs. Sometimes they can detect when you're screwing around with a process space. They can certainly detect when you're running a hacking program beside the client using the warden unless it hasn't been blacklisted yet. That's kind of like the antivirus world. But what they can't do is look into the kernel at all right now. And so there are ways to do this that Hoglund has talked about. We debated whether or not to put these into the book. And we decided not to because we said, you know, it's better if we only talk about techniques that lots and lots of people are using right now because we don't want to make game hacking worse. We just want to explain kind of what people are doing. And if we put out a rootkit-based kernel hack that's undetectable, that would just ruin the game, and that's not really the point. But you should know that this actually is happening now. Greg's going to talk about some of this in his talk tomorrow morning, so you might want to go hear that if you find this interesting. Here's kind of the state of the art. So we're going to use our injected payload stuff. We're going to cloak it, and we're going to use that whole thread hijacking thing from before. So we're still doing the debugger idea, but now what we're going to do is put control somewhere else, maybe down in the kernel, maybe at another machine, and then we're going to force events to happen in the game, just like we did with the injected DLL, but we're going to try to hide. We're going to try to remain cloaked the whole time. So here's what the architecture ends up looking like. Remember our main thread from before in the render world thing, which we can hook off of. Well, instead of using something like a software-based interrupt a la detours, we're actually going to put a hardware breakpoint in. So the machine, the client machine, actually stops, right? That process, it stops. So if it's monitoring itself, it doesn't matter because it just stopped. And then we hand control over to something, well, it could be in the kernel, or it could be on another machine. Let's say you have a dual core system, say, you know, or whatever. And then we uncloak that injected code that we've got right as the breakpoint hits. So we're uncloaking, we're running our stuff, doing all of our things over there. Then, you know, we're making setting up some calls. Then we recloak by the time we get back to handing control back to render world. So the idea is to make the exposure, the time that we can get caught screwing around with the process, both hard to find. Where is it? Is it on this machine? Is it on that processor? Is it in the kernel? And exposed in as tiny as possible a way in the thing that they watch, which is this main thread. See, but if we just stop the main thread and do all that stuff and then return control to the main thread, our window of exposure is really, 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 really small. Tiny, tiny. That's the whole idea. So this is kind of a rootkit technique that you can think of as a syringe that is just, the syringe is just sticking into user land. It's really pointy little tiny, tiny thing that's hard to find. And that's a technique that's actually pushed the way some advanced rootkits work. So Greg will talk about that more tomorrow. But pretty interesting. And that's kind of the state of the art right now in game hacking stuff. So, you know, we got our classic arms race. You got things like, this is what's happening. I love this sign. The shot up, no shooting sign. Makes me happy as a Tennessee boy. Right, so I think that these sorts of techniques that are being used now against online games, they're interesting in many capacities. I think they're interesting because you can make money doing them. So all the hackers have run off doing that. You know, if you're trying to monetize your hacking skills and you're an unscrupulous bad guy, instead of doing something like, you know, what did Skullroff do? Like blackmailing Citibank, which could get you thrown in jail, say, or in trouble with the Secret Service or the FBI, if you just cheat in games, you don't get thrown in jail for that. Right? But you can actually make money. One guy found a dupe bug in Star Wars Galaxies. He made $700,000 with that thing. He didn't tell his friends. He just used IGE to launder all that money, and he bought himself a house in Canada. If you go to his house and you ding his doorbell, it plays the Star Wars Imperial theme. It's like in deference to where all the money came from for the house. So I think we need to talk about these kinds of attacks because they're interesting from a technical perspective. We certainly moved the edge of rootkits along in online game hacking stuff. That's right where the edge is right now. It's the very, very edge. The virtualization stuff, that's also being used for these things. And we need to talk about these kinds of attacks because the way software is moving, as we build these distributed software systems that use software as a service, service-oriented architecture or whatever, we're actually going to see more and more attacks in more important software that look exactly like the things that we are seeing here in the online game stuff. So if we're smart, we'll learn our lessons by studying how these guys messed it up, and maybe even by devising some security mechanisms that can help them get a handle on this stuff. Then we'll apply those lessons to the rest of software. Now, it would have been nice if people who design games actually did what I've been preaching for 10 years, and that is software security stuff, you know. So how do you do software security stuff? Well, there's some obvious things you can do. You can review your code. You can do architectural risk analysis, and you can look for things like state confusion. Although, you know, if you look at a game, they got so much interacting state, I don't even think it's humanly possible to do it. I mean, you might be able to formalize it and turn some sorts of formal cranks. Maybe you can do that, Bill. That'd be cool. You know, but there's these sorts of things that we know we should all be doing for our software. These need to be adopted by the gaming guys too. But more importantly than that, as we move really quickly to develop future software systems, we have got to do a better job thinking like a bad guy so that we don't get all popular and then all of a sudden, you know, they come out of the woodwork and hack the bejesus out of us. And the only way to do that is to just build stuff better. So that's the ultimate take-home message. Now I'm going to give you some pointers to where to learn more and stuff that I write so that you can keep track of what's going on here. I've got a column in Dark Reading, which I think this month I'm going to talk about that notion of state. And I'm not sure when the new column's going. It's already written, so it's going up today or tomorrow sometime. But if you think about the insider attack problem, think about this. What is an insider? Well, we've always talked about insider attacks are hard, blah, blah, blah. That was network security thing. The outsiders, we're going to stick a firewall between us and them. We're going to try to reroute their packets, but we're going to drop them on the floor, whatever. Now, we've got these systems that we're building where insiders and outsiders are a big, blendy, disastrous mix. Think about that Google desktop search hack from February. The whole idea was, you know, you have this piece that runs on the PC, and it trusts the website, and they trust each other, but unfortunately you ran that piece on somebody's broken PC or the bad guy's PC. That's just as dumb as the online game thing. Oh, we're going to trust all of you guys not to cheat, so here you go. Hack the heck out of us, which is basically where we're sitting today. Does this sound familiar? What is an insider in a design like that? Well, we've forgotten about trust boundaries, right? We need to get software architects to think very carefully about trust boundaries. Here's a component, but wait a minute. Where's that component running? Why should I trust it, and how much should I trust it? These are all, you know, things that you need to think about. So that's actually what my next Dark Reading column's about. So you don't have to read it now because I just told it to you in 35 seconds. Then I've got this podcast thing that I do with IEEE Security and Privacy Magazine. And this is fun. I think my favorite one of these interviews that I've done before, so far was with Ross Anderson. So Ross and I did one, and I think it's in this month's magazine, right, Kathy? Kathy Clark Fisher's the lead editor of that thing, so if you want to talk to her. So Ross's one was fun. I've done interviews with people like, Dan Gear, Avi, are you here? Avi Rubin, Ed Felton, all sorts of people. So you can listen to those and subscribe to that if you want. I really like IEEE S&P Magazine, by the way, and you should subscribe to it for $29, just like it says. Read the slide. Then there's this book that's available now. Rumor has it that there are these little kind of thin versions of the what they called a digital shortcut, which was basically chapter 1 or something like that, that are out there on the table. And if you use the URL in that, you get 35% off the book, which is 1% more than you get off by getting it from Amazon. So I don't know if that is worth it or not, but there you go. The book is a lot of fun. There's tons and tons of code. It's a book that's best read with a compiler and, you know, a shell open. Because, oh, this stuff is so much fun to do. You wouldn't believe how much fun it's been working on this. And that's all I've got to say for now. Let's take a couple of questions. Here goes Dan. Break the ice, Dan. Or are you just running the restroom?
No. All right. Sort of a futures challenge. There is a line in the Matrix where the guy says machines hacking programs, where Neo says that.
Right.
And later where the counselor says machines battling machines and so forth. We are way past the point in complexity where you, no offense to you, or anyone else understands any of this stuff.
Right.
Simply past that point.
Right.
That means that protection of these things either requires backing up and redesign, which you know and I know is not going to happen, or it requires armaments that are self-driven.
Right.
Talk about that for a second.
So I think that's a reasonable insight. I would like to pretend to be naive enough to believe that we can convince people to do a better job architecting systems. And I worry about what happens when we use some of these security mechanisms or attack mechanisms as security mechanisms. Case in point is the rootkit from Sony. I think that that was a really damn bad idea, that Sony should not have put a rootkit on the CD to protect their DRM. On the other hand, when I have a conversation with Greg, he says, that's perfectly legitimate. Why shouldn't they use a rootkit? They can do that.
Look, not to, commit treason or anything, but
Yeah.
I work for a firm that does data security.
Yeah, Veritas.
What we sell is, roughly speaking, a data
A
surveillance rootkit.
I know.
We code inject 175 DLLs.
I know.
And we have a recording mechanism you can't turn off.
It turns out you're bad guys.
And who you well, correct, correct. And who do we sell to? People who are, in the corporate sense, employing those farms in China.
Yeah, right. Yeah, so
that's who we sell to.
So life is very interesting now. I think that we.
I did do a security plan. 3 points. Number 1 is can't reuse the tool as an attack device. Which, of course,
you can't
is a very clever goal because you never get there.
Did you wave your hands when you did that part?
Well, no one noticed that. Yes.
So we're stuck in this arms race, and it's a fun arms race, though. The thing that's really particularly compelling in this case, I think, is the economics involved and the legal situation involved. You know, all our hacking, anti-hacking law, it's all set up for attacking somebody over the network, not beating up the thing they shipped to you. So this is, the future's here. Are we going to have to resort to, programs that kill other programs? Maybe, probably. Bummer. Yes.
Now that virtual machine technology is becoming quite sophisticated, it would seem that that's pretty much the ultimate place to put a shim.
Yeah.
And by definition, in a properly architected virtual machine, undetectable to the virtual machine itself.
Right. So you look
given that isn't the only way to really end this whole thing to stop trusting the client because you can't. Not that that's necessarily practical. But I mean, that would appear to be the only way to actually properly do the security, and it doesn't appear for performance reasons that you can do that.
Yes, I think that's right. It can actually be worse than that. You could say the only real way we could do this is if we relinquish control of the chip to the corporations who shepherd our lives, Intel and Microsoft and everybody else with their little co-processor hoo-ha that does the security stuff and boots all the way up, and it's a slippery slope from.
No, but I mean, even then, you can't really but know that someone sufficiently sophisticated hasn't replaced the hardware. But you can know if you're in physical control of your servers that you have control over your servers. So it seems like the only thing to do is not to trust the client so that the users can do whatever they want to the client.
And not screw you up.
Yeah, but it doesn't appear that that's possible given the performance requirements that these guys have.
You know, you could do a lot of stuff with a VT100, so is that too much power? I mean,
Well, maybe my point isn't clear enough, but we can talk later.
no, I understand what you're saying. I think you'd have to pull everything out of the client, though, leaving nothing, which is maybe what you were saying.
Well, you don't
Except for display.
Well, no, I mean, you don't have to trust the client for things like, where you are in the universe.
Right.
You could tell the client where
Yeah, and if the net were faster, they could do some of that stuff. So that would certainly help. But right now what's happened is, unfortunately, they didn't even consider the case where people were going to misbehave until people started misbehaving. And then they had this sort of, oh darn moment. And then they've been playing catch up ever since. And so, if you can do anything to anticipate those possibilities while you're building your system, you're going to be better off.
Yeah, Gary, one of the things I would have thought would have been possible, or the first thing I'd think of is spoofing the warden, so that basically it's always saying, oh, this guy's doing good stuff. So obviously there's some authentication mechanism on the communication channel between the warden and the back end, or isn't there? Did you think about trying to hack that, get those keys?
You can spoof the warden.
Okay, so that seems like a pretty easy thing.
Yeah. And any sort of mechanism where you're putting everything on the client side and it's exposed to all the same shenanigans is trouble. The biggest design flaw in the warden is that it's a user mode process. So you can be the kernel and tell the warden whatever you need it to hear. Yep.
Well, given that that these programs are designed to run on the user's machine in their environment, you hand them all the code that they need to do that. Even the best security architected programs in the world are susceptible to these hacks and hooks and everything which you described here. Mm-hmm. How are you ever going to build a system that's going to be able to detect that these things are going on? Is there a thought like could a trusted platform modules or other things, kind of what he was saying earlier with virtual machines?
That's what we were alluding to. Some people are moving in that direction. So if you look at what, say, Microsoft is trying to do with the Xbox, although they haven't really succeeded.
With the hypervisor?
Yeah, with the hypervisor and other stuff. I mean, everything's breakable ultimately, but the question is how to make it so expensive to break that it's not really worth breaking anymore. And that's when things get interesting. So if you look at these risk management trade-offs that have been made by the financial services vertical, they have a much better handle on making those trade-offs, making it more expensive to break the thing than you get in your payoff. Right now, the scales on the gaming side are just woefully out of whack. So, it's cheap to hack the bejesus out of the client, and not only that, the payoff is huge. So that's what everybody's doing. And we need to get the scales back up somehow. How we're going to do that, given where we are now, is an interesting question. Last one.
Hi, Greg. In your definition of online gaming, do you include gambling?
Yes, and there's a lot of coverage of online poker stuff in the book.
Okay, all right.
So, yeah.
I work with the F-Secure. We have been monitoring gaming Trojans, which steal login credentials, not just for games like World of Warcraft and many other games, but also in large scale for different poker games. And I find it fascinating the way these thieves actually then steal the cash.
Yeah.
Because the obvious thing would be to wire the money away, but that's not what they're doing. They actually, log in as you, set up a new game table and play.
Right.
When they play as you, they play badly and lose their money to one of their own accounts.
And you lose to them.
Yeah, and then you next day call up the administrators and explain that yesterday evening somebody logged in as me and played badly. That's
and they're
fascinating
like,
way.
yeah, we heard that one.